two dipoles, electric dipole and magnetic field, magnetic dipole, produces torque. When you apply external magnetic field is here and external electric field is here, it is because of tendency of line up of this M in the direction of the applied magnetic field and tendency of line up along the applied electric field. That will cause rotation about the axis of this, This rotation is called as torque due to electric dipole, which is dealt with in the previous classes already. Let us see the torque due to dipole magnet in later classes. That also finds application. The torque means what is the rotation it causes? It is because of magnetic momentum. The rotation, it finds application to convert electric energy into mechanical energy, that is rotational energy, and mechanical energy into electric energy, it finds applications. And with this, we have dealt with this permanent magnet and electric field, this electric dipole. Now we have the current loop. Current means a loop carrying current. There is no magnet like this. A loop carrying current. Current strength is I. If there is a loop carrying current, as you know, according to Savart's law, any conductor carrying current induces magnetic field in its surroundings. Magnetic field, in accordance with the right hand rule, the field direction like this. So this is the direction like this. So magnetic field lines are from what is that? From up to downward like this. Example, let us illustrate or demonstrate with this. This is what the circular loop. Loop may be a circular or any shape like square or rectangle. I am taking this a circular loop. There is a loop horizontal to earth surface, perpendicular to board, plane of board. Direction is clockwise direction like this. The same thing I am keeping with ammeter like this. Here current direction is that. The current direction is that. What is the magnetic field? Magnetic field direction is this, direction like this. Magnetic field lines are from what is that? Upside to downside. That is from the upper side of the plane to the downside of the plane. That is the direction also. These represent magnetic lines of forces. So magnetic lines of forces are aligned like this, passing through the ring like this. And where the magnetic lines are generated, it stands for S pole, and here downside is N pole. They are reaching here N pole. So S pole is upside, N pole is downside. That is the case. Magnetic lines, that is induced magnetic field. So this induced magnetic field, here there is no permanent magnet, it is due to electric current. Magnetic field is induced. So magnetic lines of force here, this direction, this space, what is the space, what is that allowing or passing through the ring, we exactly behave like the bar magnet like this. Lines from south to north inside the material. Here lines from south to north through the ring. The space inside exactly behave like bar magnet. It is empty space or space occupied by the air molecules. Here there is not empty space, it is occupied by what is material, atoms and materials, magnetic material. The difference. Whether it is induced magnetic field or permanent magnetic field like this, there must have M, magnetic dipole moment. So what is that magnetic dipole? Magnetic dipole moment for this induced magnetic field. It is given by the definition expression I into A. I stands for current strength in the circuit. Current strength in the circuit. Here M stands for pole strength in the permanent magnet. And A stands for area of the circle. Bigger the area, bigger the M value. Here, to where the distance of separation between the two poles. Bigger the value, bigger the momentum. Like what? It is related. These quantities are related to this, and these quantities are related to this. M in case of permanent magnet, in case of induced magnetic by the loop current. That is what. And A means area of the circle. Area of circle means pi r square. Depends on the radius. Pi r square the area. And this area is a vector always. Direction. What is the direction of the vector? Direction of the vector. Again, the magnetic lines are what is that going like this. This is the one I am talking about. Magnetic lines are forces passing through in the direction like this. And the direction of the area is always normal. A line perpendicular to the plane of the circle. It is the direction of the area vector. It is same as the direction of M. Look at this. That is the direction of M. It is same as the direction of A. So this direction is same. That is. In case of the current flowing in the clockwise direction. If the current flowing in the anti-clockwise direction like this, it reverses the polar. That is downside, south, upside, north. Same current. A1. And the same thing what I am talking about is a loop carrying current, circular loop carrying current. Let us have different alignment. How do you find the direction of M? Here, if any loop carrying current, we need to understand, we need to perceive the direction of M, very important. So here, one alignment, here one alignment, this alignment, this alignment, this alignment is like this alignment is like this. Current reverses. To find the direction of M, we are using one more rule. That is a right hand rule. Here number of rules are there. Here the rule is for just to perceive the direction of M. If you know the direction of the current in the loop, that is a right hand rule. You have to hold the right hand like this. Right hand like this. And these fingers are in direction and this direction on like this. Perpendicular to each other. All four fingers one direction, the thumb in one direction. There is a perpendicular angle. And if you twist the fingers like this, curl the fingers like this, in the direction of the current in the loop, this will indicate the direction of M. Direction of magnetic dipole moment. This is a way of perceive the direction of M. I will illustrate with this. Here the same case I am holding it. The current direction is this. This is our perpendicular to pole, parallel to the surface of Earth. Current direction, what is that? Clockwise direction. Hold your right hand like this. Direction, you have to what is that? Swing our fingers in the direction. This. Turn or twist the fingers in the direction like this, direction of current. This will indicate, the thumb indicates the direction of M, downward. This is how it is indicated. Here, for reversing the current in this direction, the alignment is this. So this direction means swing or curl your fingers like this, twist your fingers like this. See that this will indicate the direction, upward direction for this alignment. The same ring I am holding like this here diagram, perpendicular to the pole on perpendicular surface of Earth like this. current current is going like this. So like that, this is the direction of the current. Curl your fingers and this will indicate the direction of M. Here same thing, reverse the direction of the current. Here direction of the current like this. Here direction is like this. Twist your fingers or turn your fingers in the direction like this. This will indicate direction of the current M. This is how we are using this, that is a law to understand or to perceive the direction of M. If we have the loop of any shape or size and you know the direction of the current in the loop, that is the demonstration. So this is about the magnetic momentum. Magnetic momentum and the direction due to any loop carrying current. Any loop carrying current. Of course, we can increase by increasing number of turns as well. There are some problems on this calculation of M and the direction which are useful to solve the problems of objective type. Just I call this. What is that? You are given the diagram like this. X direction, Y direction, Z direction. 3 dimension of course. Here a loop, circular loop, it is circular loop carrying current. Loop carrying current, the same thing here. This loop is in the plane of X and Z. Plane of X and Z perpendicular to Y axis. This is a loop like this. Current in this direction. Amount of current is 2 amperes. A stands for amperes. And the radius of the circle is 3 meters. That's the one we have. That is the direction. Find the magnitude of M and direction as well as. To find the magnitude, use the equation I U A. Current strength in the circuit and area of cross section. Given R, area of cross section of circle is A equals pi R square. R is given 3 square. It is 9 pi. Area of circle is 9 pi. And the current strength is 2 amperes 2. Becomes 18 pi. 18 pi is the magnitude of dipole moment. What is the direction of the dipole moment? For the direction, you have to hold it like this. Current direction is like this. That is the direction of the current. So hold your finger. That is the curl your fingers like this. See that this direction. What is the direction? Direction line is perpendicular to the plane. Which line is? It is in the direction of y. Y is perpendicular to this plane. How do I indicate the direction of y? By J. A unit vector using IJK. IJK indicate the direction of the vectors. It carries unit magnitude, direction is, so J is along y. That is y, along y is positive n. Is outside. Plus J. This is the value of m bar. Suppose the problem is the loop is not circular, it is a rectangle like this, 2 meter, 3 meter, loop like this. Current direction is this. Current strength is 1 ampere. Calculate M and direction. That is, the loop is in xy plane. It is xy plane, it is perpendicular direction of z. Find the magnitude. Phi equals 1. What is a area of rectangle is length into breadth, 6 square meter. A is 6, current is 1 equals 6. And the direction of the M, how do you find? Use the same one. It is same as what is that? Parallel to the board. Direction is like this. Direction is like this. So this will indicate what is that? Inward direction. Inward direction. M is inward direction. Perpendicular to xy plane along the z axis. But not on the positive side, it is on the negative side. Back side. So indication of z by what is that? K minus indicates it is on the negative side. 6 minus k cap. It is m, value of m. It is value of m. Direction, magnitude, direction, magnitude. These are useful to solve problems like this in CET and other competitive examples. Thank you very much.